So the last part of the study is we wanted to see if these differences in the hypothalamic response, in the hypothalamic astrocyte response is due to either hormone or chromosomal effects. So it could be chromosomal effects from the X and Y chromosome, and basically, the females have X and X and the males have X and Y, and we wanted to see if that was a main effect, or if it's more of a gonadal effect. So the SRY is the sex-determining region of the Y chromosome. So if you have the SRY on the Y chromosome, it will basically shift the development of the gonad into testes, and if you have no SRY, the gonads will develop into ovaries. And so if it's a gonadal effect, you can have two types of hormone effects, either organizational effects, where this difference in hormones and the sex hormones earlier on in development can actually change the cells, cause differentiation of the cells early on in development, and then, for instance, in the rodents, once estrogen positive feedback is gone, it never comes back. So if you take males and then you try to get an LH surge in rodents, in the humans you can, but in rodents, they actually will never have a positive estrogen feedback. And then you can have activational effects, where you're basically, at the time of your experiment, you can add certain hormones and have certain effects from those hormones at the time of your experiment. So we wanted to study some of these sex differences were due to hormonal effects versus sex chromosome effects. So for this, we used 4-cord genotype mice from Art Arnold. These mice are actually obtained from using regular females, and then the males actually have an SRY that's taken from the Y chromosome and basically transgenically shifted onto an autosome. So if they have an SRY and they have a Y chromosome, but the SRY is not on the Y chromosome. And so these are males, and then when you cross these two, you can get 4 offspring. You can have regular females, XX females that have ovaries. You can have XY females, so the X and the Y, but the Y doesn't have the SRY, and it results in ovaries. So you have XY females. And then you can have an XX with an SRY and autosome, which will develop into testes, so then you have XY males. And then you can have these, basically the same thing, you can have XY males. However, these are not the same as wild type males. And then you can compare these groups, so if you have ovaries, regardless of XX or XY, or testes, and there's a difference between these two, it's a sex effect. And then if you have basically XX or XY, regardless of ovaries or testes, you can have a chromosome effect. So we can compare the 4 groups. So what we did is we did progesterone assays, and then we incubated these 4 different astrocytes types cultures with estradiol at 1 nanomolar. And we see that in the animals with ovaries, the XX females and the XY females, that there's a significant increase in progesterone production stimulated by estrogen. And then in rodents that had testes, regardless if it was XX or XY, there was very little increase in estrogen production. So it's mostly an effect between these two and these two, so it's a pretty large sex effect. There is some difference in the baseline of the progesterone, so it hints at maybe some possible chromosomal effect. But if you remember a few slides ago, even wild-type males actually produce some progesterone, and so these male rodents actually are somewhat probably different than the phenotypically wild-type males that actually do have some progesterone response. These actually haven't been characterized, but there's actually been reported of a lot of differences in terms of function and things in these rodents versus wild-type males. So the summary of the findings: estrogen-positive feedback occurs in female rodents, but not in males, and astrocytic sex differences in estradiol-stimulated calcium elevation and progesterone synthesis could help explain some of these differences. Membrane estrogen receptor alpha is an integral membrane receptor with an extracellular portion that's not associated with the intercellular leaflet. So earlier on, it was believed that maybe this receptor is actually cytoplasmic and associated with the membrane only and doesn't stick out, but it seems like we are able to biotinylate it. And then sex differences in membrane estrogen receptor alpha trafficking could contribute to greater estradiol responses in female astrocytes. And these astrocytic sex differences are most probably due to differential secretion of gonadal hormones. However, the SRY itself can actually also have a function, and so we can't completely rule that out. So in conclusion, estrogen receptor alpha is an integral membrane receptor and is the main membrane estrogen receptor involved in female reproduction. Membrane estrogen receptor alpha activates the type 1 metallotropic glutamate receptor for rapid cell signaling, which leads to an increase in calcium and progesterone synthesis in the hypothalamic astrocytes. So I hope I can show you that I convince you that the main estrogen receptor is ER alpha and it signals to the glutamate receptor. And then the hypothalamic astrocyte response to estradiol stimulation at physiologically relevant levels may help explain the mechanism for regulation of estrogen positive feedback and the LH surge. And In addition, astrocytic differences may be the key to estrogen positive feedback occurring exclusively in female rodents, and most probably result from the differential exposure of gonadal hormones during early development. So I just wanted to thank my mentor, Paul Savage, for many years of education and support. I also want to thank the members of my lab, present and past, who helped me in my experiments, Galina Bondar, Nahid Hamid, and then Phoebe Doings here and Amy Christensen's here. Also in the past, Omid Harari, Jenny Clarkson, Julie Oji, Armando Dominguez, and then I want to thank Gautam Chaudhry, my OB/GYN chairman, for many years of support. I've been here for a very long time, and Joy Frank from the STAR program for your support, and also Dr. Slinger and Dr. Wake for being on my committee. And then I wanted to thank the NIH and the various grants for financial support. That's it. Any questions? Sure.
John, I really enjoyed that talk. It was absolutely outstanding. As you probably know clinically, it appears as if progesterone negative feedback can be blocked by androgens. And there's probably an acute effect, there's probably a developmental programming effect as well. And I noticed these candy neurons also have dynorphin. And I'm wondering if you could speculate on the effects of your findings and if you can apply them to progesterone negative feedback as opposed to positive feedback in your system. Is there a role for that? And might it be antagonized by androgens? In other words, you're speculating that the progesterone is working through hispepsin, is that right?
Yes.
But those neurons also have dynorphin? The candy neurons also have dynorphin, so I'm just wondering if there's a role for your findings in progesterone negative feedback.
I honestly don't know. I'll have to look into it. I don't know. We'll have to talk later.
John, I must compliment you again for a very lucid presentation. Far improvement, I think, from the previous one. I'm being honest.
Okay.
And then also, I'm very happy now to see that you have in your data produced different concentration-related response, which used to be absent before.
Yeah,
So
I know
that's
you
it.
like that.
Huh?
I know you like that.
Thank you. and it's really great to see you mature and become a really good investigator.
Thank you. Any other questions?
Well, if there are no other questions, I'll thank the audience for coming, and
We have lunch.
Yeah,
No,
so-
no, no,
Not yet.
we're not done.
we're not done. We're not done.
Yeah.
So,
Paul, can I just tell the others, after this, John has been recruited by a department, but only from 1st of July, don't get hired. And he will be getting his lab space and also startup funds as well.
Thank you.
So, to become really independent. But he will still have some mentors outside the department, obviously Paul will be there, but some additional people, so that he further flourish.
Thank you.
And he's joined the endocrine division, and Dan is the division chief.
Well, thank you all for coming. I appreciate the support. Thank you. There should be lunch ready. We actually ordered some lunch from Health and Peace Kitchen. It's on the 3rd floor of Ghana 3303. So you're welcome to have lunch.
well, you guys are welcome to lunch while we grill John.
Really good.
Yeah, that would be great.